Okay. All right. So how do you know whether how much force is required to do extension or retraction? So these are the equations that you need to use. Okay. All right. So hydraulic cylinder analysis is used to study three different parameters. Number one, force. Force is equal to pressure divided by area. Sorry, pressure times area. Or pressure is equal to force divided by area. So the unit for force should be Newton. Unit for pressure should be Pascal. Okay, velocity will be V. Unit in meter per second. And then power should be power, P. Okay, unit is in watts. Okay, and it is separated between extraction and retraction. As I said to you just now, the same piston, however, the area over here is AP, A piston. Okay, for this side, the same piston, but we have two different area for you to take care of. Okay, this is A piston, and then we have this as A rod. Okay, piston and rod. So this is the surface area for our study. Okay, so extension stroke. To find out what is the force, force of extension is equal to P in Pascal multiplied by AP in meter square. So AP is the area of piston. To find out AP, it should be pi d square over 4 or pi r square. Which one that fits you nicely? So you can do whether pi d square over 4 or pi r square. So that's for the area. Okay, and then for the velocity, we need to remember the equation of Q, volume flow rate, is equal to AV. So V is equal to Q divided by A. So volume flow rate in divided by area of piston. Okay, the different part for this one, retraction stroke, same equation, but instead of A piston, we have to minus the area for rod, so that AP minus AR will provide you with this area over here. Okay, so V also can be found using Q divided by, AP, divided by A, so AP minus AR also. So we use a different area here. So this area will not be the same. Okay, and lastly, to find out power, okay, in watts, for example, in kilowatt, we use kilopascal. In watt, we use Pascal only. We can do it by having P times Q or F times V. Okay, F is the force, V is the velocity, P is the pressure, Q is the volume flow rate. Okay, so you'll get power in terms of watts. How about another one called as horsepower, HP. Horsepower is when you have your power and then you divide it with 745.7. Then you will get horsepower. Okay, so usually when you study about power, it's either you get it in terms of watts for electrical power. Sometimes for car, for example, they use horsepower. To find out what is horsepower, it's 745.7. You also learn about power in air conditioning, correct? Refrigeration and air conditioning system, I guess from MEC 351. So you also have to know the horsepower. So usually at your house, we use 1.5, 1 horsepower. A bigger one will be 2 horsepower. So that's a way for us to provide an idea what is the power of the system. Okay. So power divided by 745.7, you get it in terms of horsepower. Unit dia ialah HP. Okay. Any question on this? No, Okay, so this is an example of the question. A pump supplies oil at 0.0053 meter cube per second. So this will be your Q. Okay, for this particular study, hydraulic cylinder, we don't have this wording over here does not represent actual or theoretical. So we can just assume, sorry for that sound, we can just assume that the Q over here is the one we are using, is input Q. 7.1 centimeter double acting cylinder, so 7.1 cm diameter. This should be representing the diameter of piston. Okay. If the load is 700 Newton, so F, okay, extending and retracting, meaning F extend equals to F retract equals to 700 Newton. And the rod diameter is 4.23 cm. So this is D rod. Okay. Find the hydraulic pressure during the extending stroke, piston velocity during the extending stroke, cylinder horsepower, hydraulic pressure, piston velocity during retracting and retracting stroke. So ABC over here is for extension. Okay. DEF over here is for retraction. Okay, so extend, retract, 3 different questions here. They are asking for 3 different equations, and we can just use the equation that we have over here. Apa nama nak kena ni? Aizat, question 1. A. Sorry, question A, apa jawapan dia? Aizat.
Nak tanya.
Ya, boleh.
Yang horsepower tu kan, power tu nak guna kilowatt ke watt je?
Watt je. And then bagi dengan horsepower tu.
Okay.
Okay, Aizat jawapan apa Aizat? Tak ada jawapan. Alistair ada jawapan?
Saya ada.
Ya ada. Bolehlah tanya, jawab.
Tapi tak sure betul ke tak.
Betul lah, logik lah tu.
Yang extending tu, dia punya pressure dia 176.803 kPa.
Okay, ni 176.81 kPa. Alright, good enough. Okay, thank you. Okay, so the answer is already here actually, dalam saya slide. Okay, first what you need to do is make sure you find out what is the area of piston. And what is the area of rod? So it's easier for us to do the calculation. Then P extension is just F divided by AP. Should get this number, the same just now. Okay, V extension should be Q over AP. It's simple, 1.339. And then find the power in terms of watt. Don't find it in terms of kilowatt. Then divided by 745.7, you get it in terms of horsepower. Okay. All right, this is for extension. Okay, this is for retraction. So retraction, the difference is here, AP minus AR. So you can see from here, the pressure will be higher, velocity will be faster, and the power for the retraction will be much higher, horsepower will be much higher, meaning due to the area difference between AP and also AR, okay, so due to this area difference, okay, so it will increase the amount of pressure required because the area is becoming smaller, the force is the same, so pressure will increase. When the pressure increase also due to this velocity calculation, okay, when we have constant volume flow rate, the velocity will also increase. And lastly, the power will also increase, meaning smaller area requires a higher power to push it back to the original position. So meaning right now, extending is much easier than retracting in terms of power and force. And that will be the case based on this calculation. Okay? Boleh lah kan? Tak susah sangat kan?
Yeah.
Alright. Okay, thank you. And as usual, when you have formula related to this hydraulic condition, we will have this formula again. The same as pump, you have theoretical torque, okay? So VD should be in meter cube per revolution. Pressure should be in Newton per meter square. Okay, so you multiply these two divided by 2 pi, you'll get in terms of Newton meter, the theoretical torque. Okay, theoretical power, HT, or this can be H, can be P, W dot, any notation will do. Okay, it will be TT times N divided by 2 pi. Theoretical flow rate will be VD multiplied by N in meter cube per second. Okay, this one TT should be in Newton meter, N should be in radian per second. All right. Volumetric efficiency, QT over QA. So remember, this is for motors. It is the other way around compared to pump. Okay. So for motors, it is QT divided by QA. For pump, it is QA divided by QT. So do not mistake this. So this is very important. This is okay. This is also the same. It is inverse from pump. Meaning for pump, it is TT over TA. Okay. But for mechanical efficiency for motor, it is TA over TT. So please be aware, make sure the equation is correct so that when you do the calculation, you will get the right answer. Okay. Any question on this?
No, sir.
No. Okay, remember dia ada perubahan So let me do something here. Okay. So for in case okay, this is for pump. This is for motor. Okay. For pump is equal to QA over QT. For motor, it will be QT over QA. Okay. And then the next one will be for mechanical efficiency. It should be TT over TA. This one will be TA over TT. Please do not get confused with this. Make sure you know whether you are dealing with pump or you are dealing with motor. Other than that, the equation should be the same. Okay. So this is another example of study on hydraulic cylinder. Okay. A hydraulic motor has this number if it has a pressure rating. Okay. So this question is here and the answer should be here. Okay. So I'll go through one by one, simple. Okay. First, hydraulic motor has a 0.0000819 meter cube volumetric displacement. So this represents VD. Okay. If it has a pressure rating of 6.9 times 10 to the power of 6 Pascal, this is the pressure. Okay. And receive oil from a pump at a theoretical flow rate of 0. Okay. So this is QT. So find the motor speed, theoretical torque, and theoretical horsepower. So to find this up, to find the speed, first we need to know what is the speed from QT. So before this, we do not know VD. We have to calculate VD. Now VD is provided, QT is also provided. So we need this in terms of meter cube per N should be in terms of revolution per minute or revolution per second. So to find this out, okay, N is equal to QT. Since this is in second, meter cube per second, you divide it by VD, meter cube per revolution. This cancel out. So at the end, you will have the answer in revolution per second. So this is the answer for N. Okay, please be aware whether we are using meter cube per second or meter cube per minute. If this is meter cube per minute, the answer will be revolution per minute. Okay, so the question asks us the speed, but does not require us to use in terms of RPM or meter cube per second. But if you want to find out what is it in RPM, it's just 60 seconds divided by 1 minute. So you get the answer in RPM. So both answers are correct. If they did not ask us whether to go for RPM or for revolution per second. Okay. Dalam ni ada cakap kena dalam RPM ke? Tak ada kan? So, boleh dalam jawapan macam ni, boleh dalam jawapan macam ni juga. Tak ada salah mana-mana pun tak salah. Okay, then they find, we need to find theoretical torque. So theoretical torque is VdP over 2 pi. So Vd, we already have the number here. Multiply by pressure, then divided by 2 pi. So you get the answer 89.94 Newton meter. And then they say about theoretical torque, theoretical horsepower. So first we find power first, PT. So theoretical torque times N. When they say theoretical power, TTN. If they say actual power, TAN. So just change between theoretical or actual. Okay. So this number 89.94 multiplied by 462.3 revolution per minute. Okay. What we do here is we change from minute to second and then we multiply by 2 pi radian. Okay. So it's either you use your RPM and then change it from revolution to radian, multiply it by 2 pi and change it from minute to second divided by 60. So, or either you use the 7705 revolution per second, multiply by 2 pi only. So, depends lah. Faham-faham sendiri lah. So, from revolution to rad, multiply 2 pi. From minute to second, divided by 60. So, this should be in radian per second. Okay. TTN should be radian per second. Tadi saya ada tuliskan, dia mesti dalam bentuk radian per second. Okay. Theoretical flow rate ni can be in RPM ataupun can be in revolution per second. Okay, so this is the answer. And then horsepower, whatever power that you get, do not make it into kilowatt. Make sure it is in watts divided by 745.7. So you will get it as horsepower at the end. Done. So this will answer the first question. Any question?
No, sir.
No, okay.
No
The
question.
next question
Okay.
is,
No question.
yes, the next question, yes. Tak ada Okay. Alright, so question number 2 will be on a hydraulic motor has a displacement of 164 cm cube. Okay, when you talk about displacement, you should know this is about VD. Okay, and it is in centimeter cube. It does not mean that we don't have per revolution. So you need to know this is cm cube per revolution. Okay, and operates with a pressure of 70 bars. Okay, given to you, pressure equals to 70 bars, which is 70 times 100 times 10 to the power of 3. Okay, so remember 1 bar equals to 100 kilo Pascal, or okay, with a speed of 2000 RPM. So this is N in RPM. If the actual flow rate consumed by the motor is actual flow rate, so this is QA. And the actual torque delivered by the motor is 170 Newton meter. So actual torque, TA. Okay. Find volumetric efficiency. Okay. Mechanical efficiency, overall efficiency, and the actual horsepower. This is the same as what we did before, but instead of pump, we are using motor. Okay, so first, make sure you change from cm cube to meter cube. How? 1 meter cube is 100 cube centimeter cube. So this cancels out and you'll get the answer in meter cube per revolution. And then multiply with 2000 RPM, you get the answer in meter cube per minute. However, your QA is in meter cube per second. So change your QT from meter cube per minute to meter cube per second. So this is the answer for QT in terms of meter cube per second. So how we will continue with this? So QT divide by your QA, so you will get the answer 91.11%. This is based on the equation for motor. All right. And then the next part is to find TT. TT is VDP over 2 pi. We find TT over here, 182.71 Newton meter. Then using the equation for mechanical efficiency, TA over TT, you will get the answer to be 93.04%. Okay, you can also use the equation that we learned last time, but the equation will be different. So I prefer you to use this one. Find TT first, then divide it by your TA. Next, overall efficiency is just multiplication of volumetric efficiency times mechanical. So you get in terms of 84.76. And horsepower, whatever that you have for the power. So the question asks us actual horsepower. So we use the value for TA. Okay, so TA, N must be in again radian per second. So whatever that we have in revolution per minute, change it into radian per second. And to find out what is a horsepower, you just divide it by 745.7. So this is the horsepower at the end. Okay, any question for this one?
No.
No. Laju je, no Okay. Sorry.